Hey, chemistry students, we're back at it again. Today's lesson is going to be on isotopes and percent abundance. And what does that mean? We're going to learn how to calculate the atomic mass of an element. And when we're given an element with a charge, which we haven't seen yet, we're going to find out the number of electrons. Okay, so make sure you have something to write with. Let's take some notes. All right, so atomic mass unit is defined as 1/12 of the mass of carbon-12. We measure all elements against carbon-12. That's the standard. The atomic mass of an element is a weighted average mass of the atoms in a naturally occurring sample of the element. A weighted average mass reflects both the mass and the relative abundance. That just means how much of the stuff is out there in nature of the isotopes as they occur in nature. So maybe there's more carbon-12 than there is carbon-14 out there. That's all. So let's just take a look at where we're going to find the average atomic mass on a periodic table. So it's the larger number, and it usually has a decimal. And it has a decimal because we are taking the average of all of the masses of the isotopes that we find in nature. And we're just taking an average. Just like if you were to take the average of your test scores, let's say in math or chemistry, you would add up the number, and you're not going to get a perfect answer. You're not going to get 85. You're probably going to get 85.4577, something like that. Okay. And this is what it looks like on the periodic table. And we get this because we take the mass of the isotopes and we do some calculations given the natural abundance. Okay. And natural abundance, again, just means how much of this stuff is out there in nature. So to calculate the atomic mass of an element, we're going to multiply the mass of each isotope by its natural abundance. And we're going to change this percent that we're given into a decimal, and then we're going to add the products. So we're going to multiply, and then we're going to add. All right, so let's do an example. Make sure you write this down. Chlorine has two isotopes. We have chlorine-35 and chlorine-37. You are given that chlorine-35 has an atomic mass of 34.969 and is found in nature about 75.77%. A little more, well, actually a lot more than chlorine-37. So chlorine-37 has an atomic mass of 36.966 and is found in nature 24.23%. So we're going to do a little calculating. So we're going to let's just take a look at this is chlorine-35. It has 18 neutrons compared to chlorine-37, which has 20 neutrons, right? And that's why the nucleus over here has a couple more green dots. Those are the neutrons. We're going to see that protons are the same and electrons are the same. We're going to find in nature, though, if we were going to be out there hunting for chlorine, we're going to find that 75% of the species that we pick up are going to be chlorine-35, and maybe about 24% will be chlorine-37. Let's do the math, y'all. Let's go. All right, so we're going to take the atomic mass of chlorine-35, which is given to you. We're going to multiply it by the percent, but we want the percent to be in a decimal. We're going to move the decimal point over 2 places to the left. That's where we get this 0.7577, and we put that in our calculator. We're going to get this number, 26.4960113. Easy, right? Next, we're going to take chlorine-37, take its mass, which is given, and multiply it by its percent. We're going to change that percent to a decimal, 0.2423. We're going to multiply. We get 8.9568618. Now, the last step will be to add these two together. Boom. If you get out a periodic table right now, you're going to look at the tile for chlorine, and you're going to see that chlorine's atomic mass is 35.453. That's where the number comes from here. We actually round. We're going to take this 8, and the 8 tells us to round this 2 up 1. So that's where we get the number on the periodic table, 35.453. So we take the average of the masses of all the isotopes we find, and then we plop it right down there into the periodic table. And that's it. Let's review, and we're going to add one more calculation to figure out how do we figure out electrons when we're given a charged atom. Okay, so atomic number, easy. That's the number of protons. You can get that from the periodic table. Electrons, how do you find electrons? It's the number of protons minus the charge. Okay, that's the new calculation we're going to do today. Neutrons, how do we find neutrons? We take the mass number, the big number, minus the atomic number. Mass is the same thing as the protons plus the neutrons. And then the charge, how do we find the charge? Well, we're just going to take protons minus the electrons. So let's do some of these examples here. Just one. Copy this down. All right, so if you're given a chlorine atom and there's a -1 here, that's the charge on chlorine. Chlorine right now is an ion. An ion is a charged atom, and chlorine's charge is -1. Let's figure some things out. All right, mass number, easy, given. Atomic number, easy, 17. If we have the atomic number, we also have the number of protons. Boom, 17. Neutrons, how do we figure out neutrons? Easy, we're going to take mass minus atomic number. So mass minus the protons, 35 minus 17, boom, 18. Electrons, how do we figure out electrons? This is not as easy. Before we said, oh, it's a neutral atom, we'll just take the number of protons. No, this time it's a charged atom here, so it's a -1. So to find electrons, we're going to take the number of protons minus the charge. So I give you the charge of -1. So 17 minus a -1. Remember, you have two negatives together. That'll be a plus plus. And we're going to get 18. Okay? And that's it.